Hi, welcome to another episode of LoveTech Live. In this episode, we'll be covering Microsoft SQL Server and SQL Studio by using a simple example of creating a video storage site like YouTube, where users upload, watch, and rate videos. We'll cover creating the database, creating the tables, inserting data, altering tables, and more advanced queries. If you were to actually compete with YouTube with video storage, you'd probably need a larger scale database solution like Google BigTable or BigQuery to store hundreds of millions to billions of records. The first step is to open Microsoft SQL Server Management Studio, right-click on the Database tab, and click New Database. In the dialog that opens, type in Video Storage, or whatever you want to call your database. And then you're going to right click on it and do New Query. And that'll open a document that'll allow you to type and run queries. So the first two tables that we want to create are users and videos. For the users table, we want 3 columns: first name, last name, and email, all with varchar of 512. And then we want to create a videos table with the title and description. So we'll start simple. We can add additional columns later to show you how to do that, but we'll run these. And here's a trick when you're using Studio. It only runs whatever you have highlighted. If you don't have anything highlighted, it'll run the entire query file, but if you highlight one portion of it and click execute, it'll only run what you have highlighted. So now we have 2 tables inside of our database: users and videos. So let's add some users and some videos. And then let's check to make sure that we've added what we wanted to add. So I'm realizing I should probably explain this a bit more. So when I run these insert queries, first I specify the table name. So I say insert into the table name, which is either users or videos. I specify the column or the field list. Then I say values, and then I specify the values for each of the columns that I put in parentheses after the table name. So it's a real simple example. And then the select will show us at the bottom of the table here the data in grid format. It's also the same query we're going to run from our code to get data for our application. So you can see we have 5 users and 3 videos. Now, a common thing that you're going to want to do in all of your tables, or at least most of them, is have an ID. So there's 2 different types of IDs that you'll find yourself using. One of them is an auto-incrementing integer. So the first record will have ID of 1, second record ID of 2, and so on. And the other type is to have a random GUID of just random letters and numbers. And the benefit of having an integer ID is it allows you to join against other tables more efficiently and do faster lookups. The downside is that it creates a predictable pattern. So people can guess these IDs pretty easily when they know that they're an integer that just goes up by 1 each time. So just choose what's best for your use case. So let's run these queries. We'll add an ID to users, add an ID to videos, and then let's try it out here. So the queries I just ran were alter table queries. So this takes a table that already exists, and it does. You can do all sorts of different things with alter table. You can change the default value, the column type, and so on. But the add clause command will add an additional field or column to your table. So in this case, we're adding an int ID, and this is a special phrase that basically says start at 1 and increment by 1 each time. So now let's do our selects again, and now you can see we have an ID for each of the rows. So next, let's just do a test here where we add another column, or excuse me, another row. And then we'll make sure that that gets a new ID. So that gets ID 6. And that gets ID 4. So that's perfect. So in YouTube, what they have is the notion of who uploaded each video. So if we go back to, so right here in our videos table, we know the title, description, and ID for each video, but we don't know who uploaded it. So the easiest way to track that, since each video will have exactly one uploader, is to add an uploader column to our videos table. And it's going to correspond with our user's ID here, which is an integer. So we'll put the same type here. So we'll alter table videos, and we'll add a new column, uploader, of type int. And just to show you, when we first add a new column and we don't specify a default, like I could have said default 1, and that would make everything 1 to start off with, or if you don't specify. But what we want to do, well, what we just did, we didn't specify a default, so we'll see nulls in all the spots. So let's address another type of query called update. And the way this works is it's going to affect a table, and it has a set clause and a where clause. If you don't have a where clause, it means to do it to all the rows. But let's add a where clause here where ID is equal to 1. So this is going to update our Bohemian Rhapsody music video, and it's going to set the uploader to 1, which basically is saying that John Appleseed was the guy who uploaded it. So we got that. Now let's take out the where clause, and we'll do all of them all in one go. Now it's worth mentioning that you should be very careful when you do your updates and your deletes, that you don't run it without double checking it, because you don't want to adjust any queries or any data that you're not trying to affect. For instance, if you had a popular site in production and you ran this query, you're going to lose who uploaded each of your videos, and if you didn't back up your data, you're going to be hosed. But this is just an example, so we're updating all the videos so that we don't have any nulls. So we're going to say John Appleseed uploaded all these videos. Now, to make things more interesting, let's clear out those queries, and we're going to add a couple other tables here. One called video views, which has the video ID, the user ID, and the date that the video was viewed. And video ratings, which tracks who rates which videos, when they rated them, and what they rated them. And let's add some data here. So let's just look at one of these lines here. So we're inserting a view saying that user 1 viewed video 1, and get date means now at this point. There's also get UTC date, which is probably a better function because get date is going to have the date based on the server time. Get UTC date is going to have it based on the universal time. I forgot what the C stands for. Coordinated time, I think. Universal coordinated time, which means that no matter what the server's time zone or the user's time zone. Everything's normalized to a specific time zone that we know, and then it's converted as needed to display for any given user. So if you go to Twitter or YouTube or Facebook, you're going to see all the timestamps relative to where you are in the world, specifically what you have set for your computer's time and date settings and time zone. But I just wanted to point that out. Get UTC date. It's also called GMT, Greenwich Mean. That's your best friend. And just to point it out, if you're in JavaScript, if you're developing a website, you need to check out the moment.js library. That's your best friend. So let's view all of these video views. And you can see it's putting them in at 1:42, which is my computer's time right now. And then if we do a get UTC date, it's 6:44. So let's use a UTC for these other ones. So these, oh, I already ran these. So an interesting thing to point out that I don't think I mentioned was primary keys. So what I'm basically saying here is that I want to create an index, a constraint that means I can look up data really fast given these common lookup fields. It also says that I'm never going to have two ratings for the same combination of video and user. Because if you think about it, say somebody rates something 3 stars and then they come back later and they rate it 5 stars, or in YouTube terminology, if they give it a thumbs up and then they come back and give it a thumbs down, that should replace their old rating. Of course, your video site might be different than how YouTube works, and maybe you want to track the history of how people change over time. But that's not very feasible in these days. There's so many videos that people kind of watch something once, give it a rating, and move on. So you can see, since we had this primary key, when I reran this query, it says, oh, I already have user 1's radio for video 1. So what you have to do is, at this point, do an update. Update video ratings, set, say we wanted to change him, he came back, it's an acquired taste, for instance, and we want to say set rating equal to 5, where video ID is equal to 1, and the user is 1. Another case where you want to make really sure that you don't accidentally update everybody to 5 stars for everything they've ever rated. That's why it's really important. You'll usually always have a very restrictive where clause on all your updates. I had another thought. I guess we'll move on. Here are some fun functions that I wrote up that I wanted to share. So for the first set, we want to select the video ID and the total views from each video. So this is a select like we were looking at before, except for we're specifying, well, first off, we group up by video ID. And this is a really important clause for aggregate functions. So we care which video we're talking about and what the total views were. So we're using this aggregate function called count star, which counts the number of rows after we group them by ID. So this gives us all of our total views by video. So we can see one was viewed the most, the others were each viewed 2 times. And if we went up to here, you'll see one was viewed 4 times. And remember, I ran this query twice, one with get date, one with get UTC date. So that's 5 times. And then these each have two views for 2, 3, and 4 video IDs. So this is getting a little bit more fancy. but it's good to look at. So this has a subquery and an inner join. So a subquery lets us build combination queries. So what the subquery says is it's basically the query that we just ran. So count up how many times each person or how many times each video was watched. And then inner join takes two result sets, either tables or results from a subquery, and aligns them together based on the on clause. So our on clause is where the subquery result, or .video ID, so that's these right here, 1, 2, 3, 4 video ID, is equal to our videos table.id. And then we order by total views descending. So what this is going to do is it's going to take this query and it's going to bring in the title, basically just the title, so we know what we're looking at a little bit better. See, we have the title now. Also, we sorted the results by the number of views. So imagine if somebody comes to your site and they click, show me the most popular, the hottest videos. This query in one swoop tells you what are the most popular videos, what they're called, what their IDs are, and how many times they were watched. So it's much more efficient to do something like with a join than to do something like this and then do a bunch more queries to look up the title for each result. So let's look now at another aggregate function. Just like count is an aggregate function, average is an aggregate function. And the thing to remember about aggregate functions is that you always need to have a group by. So in this case, we're grouping by the video ID again, and we're counting how many times it was rated. Before we're counting how many times it was viewed. How many times was it rated, and what was the average rating? So that gives us some interesting metrics. And just like before, we're going to do the same thing as a subquery and then join on the video information, specifically the title. So this was video-based stuff. Now we're going to user-based stuff. So the big change here is instead of grouping by the video ID, we're going to group by the user ID. So we're going to see who has the harshest tastes, who are the trolls, who are the people who love this content. So we're grouping by the user ID, and we're looking at how many they rated and what their average rating was. And then this time we're going to group in and we're going to bring in the user information, such as the first and last name. So that's everything for now. In the next episode of Love Tech Live, we'll look at the Apache Mahout library to explore how we can use linear algebra to give personalized user recommendations to our site visitors. Thanks for tuning in to this episode of Love Tech Live. If this video was helpful, click that like button, subscribe, and ring the bell. Check out the description box of this video or just go to lovetech.io for more plugins and tutorials.